Okay, this is take 3 of multiplying and factoring monomials and polynomials from the Polynomials and Factoring chapter. Let's see how this take goes. So, to multiply a monomial, meaning one term, by a polynomial, one or more terms, you can use the distributive property. So, for example, to find the product of 2x, a monomial, and 3x plus 1, a polynomial, we use the distributive property. So I'm going to multiply 2x times 3x and 2x times 1. When we do that, we use the power rule. No, we don't. We use the product rule. The product rule says that if we are multiplying exponential values, we keep the base and add the powers. So I'm going to multiply my coefficients first. 2 times 3, I have 6. And I'm going to multiply my powers. So I have x to the first power. Remember, if there's no exponent, we know that it is to the first power. So I'm going to keep my base and add my exponents. So x times x is x squared. Now I'm going to multiply 2x times 1, so plus 2x. Another way of finding the product of monomials and polynomials is to use algebra tiles. So before you will end up seeing these x squared blue tiles and green tiles, we're just going to start with 2 x's for our 2x term and our 3x plus 1. All you will see at first is everything except the tiles, so just the black x's and the 1. And we are going to multiply them. So I have x times x, which will then give me x squared. X times x, x times x. So this is basically a longer process of the distributive property. X times x, x squared, x times 1, x. Again, we have to multiply everything by our second x. So we have x squareds, and then we have x. So our final result gives us 6x squared tiles and 2x tiles. If you prefer to use the tile method or want to learn a little bit more about using them, please see me in class. I will give you some to use. So let's jump right into another example. This polynomial has an extra term compared to our first example. So once again, I'm going to use the distributive property. So I have negative x cubed times 9x to the 4th, negative x cubed times negative 2x cubed, and negative x cubed times 7. So again, we're going to use the product rule. So I have 9 times negative 1, I have negative 9, and I have x cubed times x to the 4th. I'm going to keep my base and add the powers. So negative 1 times negative 2 is a positive 2. X cubed times x cubed, x to the 3 plus 3 power. And I have negative 1 times 7, negative 7x cubed. And now I'm going to simplify. So I'm going to add those exponents together. So negative 9x to the 7th power plus 2x to the 6th power minus 7x cubed. So, to get my final product, I multiplied my monomial by each of the monomials within the polynomial. Those words are really twisting my tongue, like total tongue twisters. I think they did in the first video too. I'll work on that. Apparently my computer is being slow as well. So, moving on. We have another example. You probably guessed that you're going to have to do a couple of these on your own. This is one of them. So, use the procedure that we used on the first page to find the product of 5n times the polynomial 3n cubed minus n squared plus 8. So that is multiplying monomials and polynomials. So much fun. It gets even more fun. Here we go. Next, we're going to talk about factoring. So factoring a polynomial reverses the multiplication process. You factored out constants of terms either last year or a couple years ago. Now we are just adding variables because why not? So when factoring a monomial from a polynomial, the first step is to find the GCF, greatest common factor, of the polynomial's terms. So to find the GCF of a polynomial, we're going to list the prime factors of each term. Remember, prime numbers have factors of just 1 in themselves. So I'm going to identify the factors common to all the terms at the very end. First, I'm going to list the prime factors. 5x cubed, well, that's pretty nice because 5 is a prime number. So it has prime factors of 5 times x times x times x. This is the prime factorization of 5x cubed. Next, I need to list the prime factors of 25x squared. So 25 is not a prime number, it is composite. So the prime numbers that multiply together to give me 25 are 5 times 5. And then I have 2 x's. Don't I wish? Next, I need to find the prime factorization of 45. I don't know those prime factors off the top of my head, so I'm going to use a factor tree to find those prime factors. So to the side, prime factorization of 45. What two numbers multiply together to give me 45? 5 and 9 can. 5 is a prime factor, but 9 is not. So I have to keep factoring to get prime factors. There are a couple methods to do this. The one that I predominantly use are the factor trees. You can use whatever method that you have learned in the past. So I now have prime factors. This is the prime factorization of 45. So 5 times 3 times 3. I'm going to list those next to my monomial. So 3 times 3 times 5, and I have an x. So now I need to identify the factors common to all of the terms. So each and every one of these terms has a 5 in common. There are no 3's in these two monomials, so we don't have any 3's in common. Do we have x's in common? It looks like it. So each monomial has an x term in common, just one. If 45x had an extra x to it, we'd have 2 x's in common. But since 45x has only one x, we can only use that one x for common factors of all 3 monomials. So now the GCF are the terms in common multiplied together. So we have a 5 in common, and we have an x in common to all of these terms. So when we multiply that together, we get 5x. That is how you find the GCF of a polynomial. So this is going to be the first step when we are factoring out a monomial. So let's just practice this first step, just finding the GCF. So you have an example here. Please do this on your own using the same procedure as above. So once you find the GCF of a polynomial's terms, you can factor it out of the polynomial. And that is our goal for this chapter, is to be able to factor out monomials from polynomials. So first I'm going to find the GCF. So we need prime factors of 4x to the 5th. I know that 2 times 2 is 4, and those are both prime numbers, so that is absolutely perfect. And I'm going to list all of my x's. Next, I need to find the prime factorization of 24x cubed. Don't worry about this negative right here. That comes later. For now, we're just going to find the prime factorization of 24. I don't quite know that off the top of my head, so I'm going to use my factor trees to find the prime factorization. So I know that 4 and 6 multiplied together give me 24. So neither of those are prime numbers, but I know that 2 times 2 will give me 4, and 2 times 3 multiplied together will give me 6. These are all prime factors. So the prime factorization of 24x cubed is 2 times 2 times 2 times 3, and I also have 3 x's in common. Not quite in common. 3 x's to be factored out, I'm sorry. So I have 8x. I know that the prime factorization of 8 is 2 times 2 times 2. If you did not know that, you can certainly use factor trees. Find the prime factorization of 8. 4 times 2. 4 is not a prime number, so 2 times 2, and bring down that 2. And I also have 1x to factor out. So now I need to find the factors in common of all of these terms. So I notice that I have 2 sets of 2's in common with all 3 terms, and it looks like I have 1x in common with all 3 terms. So I'm going to multiply all of those factors that I have in common. So I have 1 2, 2 2's, and 1x. The product of 2 times x is 4x. So that is the GCF. Now I'm going to factor that GCF out of every term. So I'm going to take a 4x out of my first term, 4x to the 5th. When I do that, I just have x to the 4th left. To make sure that we factored out correctly, you can multiply these 2 terms to see if the product is in fact 4x to the 5th. We have 4x times x to the 4th is x to the 5th. We did that correctly. So I'm going to factor out a 4x from my next term. Once I factor a 4x out of 24x cubed, I will have a negative 6x squared. Multiply those together, I get negative 24x to the third, perfect, plus 4x, and once I factor a 4x out of 8x, I just have a 2 left. 4 times 2 is 8 times x, 8x. So I am now going to take that 4x out. We're going to clean this up a bit. So I'm going to have 4x times everything that was factored out. So I have 4x times x to the fourth minus 6x squared plus, that's a plus, 2. And that's it. That is the factored form of the polynomial. It's a lot easier to manipulate when we have a simple factored form of a polynomial compared to what we started with. It is a very long process, but it's absolutely doable. You have the knowledge and understanding to be able to perform these. So, in sum, you're going to find the GCF. Once you have found that GCF, you will factor it out of each and every term. So you take out a 4x. What times 4x will multiply together to give you 4x to the fifth, x to the fourth. I want to take a 4x out of 24x cubed. If you don't know how to do that, you can divide. So divide each and every term by 4x. That is how we quickly factor that GCF out. So if you really don't get how to factor it out, divide every single term by 4x, and that will use the quotient rule. So please do this next example on your own. I have it nice and broken down for you to be able to find your GCF of all three terms. You're going to factor out the GCF from every term, and then you're going to clean it up and find the factored form of the polynomial. That'll take you a couple minutes, so you can either pause the video and do it while it's fresh in your mind, or you can come back to it. Next, we're going to get into a word problem, your favorite. So, this word problem is a rather large problem, so we're going to walk through it together. So we're talking about helipads. These can be found perhaps on top of hospitals, on top of rather large buildings. So, a helicopter landing pad or helipad is sometimes marked with a circle inside of a square so that it's visible from the air. So, we want to find the area of the shaded region of the helipad, and they want us to write our answer in factored form. So, our helipad, we have a circle inside of a square, and they want us to find the area of the shaded region. So, if you notice, the circle is inside of the square. So, we need to find the area of both the square and the circle. We are going to subtract the area of the circle from the square to give us the remaining space. So, the area of the square, we're just going to write the formula. So, A of a square, that's a square, is S squared. So, side squared. So I'm going to substitute 2x for s. since it is a square, I know that each one of my sides will be length 2x. So we don't have the exact length of each side, but it's giving us 2x. So substitute 2x for s, which equals 2x. So all I did was substitute the length of the side of my square into my formula, and then I'm going to square it because that is the formula of a square. Now I'm going to simplify using the power rule. So 2x squared, I'm going to square 2, which is 4, square my x squared. Remember the power rule, I need to multiply my exponents when I'm raising a term to a power. Next, I'm going to find the area of the circle. Area of a circle is pi r squared. Pi r squared. Now, my radius of the circle is given to me in terms of x. So I'm going to plug x in for r. So I'm going to have pi, I wish I was having pi, x squared per my formula. So I substituted x in for my radius, and I have the result pi x squared. So the area of the shaded region is the area of a square minus the area of the circle. So I'm going to take the area of the square, which is 4x squared, that was the area of the square, and subtract the area of the circle. So pi x squared. So 4x squared minus pi x squared. That is going to be the area of the shaded region. Now, this isn't fully factored. I need to factor the form of the area of the shaded region because that's what they asked us to do, was to write our answer in factored form. If they did not ask us for the factored form, we would keep this answer, but we have to further factor it. So we are going to find the GCF. So I need the GCF of 4x squared, and I need the GCF of pi x squared. So prime factorization of 4x squared is 2 times 2 times x times x. Prime factorization of pi x squared is pi times x times x. So I have to identify the factors in common to both terms. I have 2 x's in common. So the GCF is x times x, which is x squared. Now I'm going to factor out the GCF from each term. So I have x squared. I need to factor that out of 4x squared, so I will just have a 4 left, minus, remember that it was 4x squared minus pi x squared, so minus x squared. All I have left when I factor that out is just pi. So now I'm going to clean it up a bit, identify my x squared being factored out, and I have a 4 minus pi left. 4 minus pi. So the factored form of the area of the shaded region is x squared times 4 minus pi. So that is it for your notes section. You have a few practice problems to do on your own. If you have any questions, please bring them into class. Thanks for enjoying your second video. We'll see you in class.